Right, students, welcome to your last lesson of your matrix unit. This will be covering chapter 8.7, which is on simultaneous linear equations. Now, before you do this lesson, you need to make sure that you're able to do the two previous ones. So 8.5. So these questions. So watch the video for this, and also 8.5i. But more importantly, I think the previous one's really good, 8.5. So please make sure you watch that to be able to do these questions. Okay, let me go through this. So it says here, a set of simultaneous linear equations with two unknowns, x and y, is a pair of equations that can be written in a form. So these basically are two linear equations. Okay, and they are, it's called simultaneous, is because there's two, that's why. Simultaneous just means at the same time. Okay, so there's two linear equations here, and you can see them, it's in this form. Generally, with your linear or simultaneous equations, okay, you've got some unknowns in there. Now, the number of unknowns depends on how many equations there are. Because there are two equations here, okay, equation 1, equation 2, you're going to have two unknowns. There's x's that are your unknowns and y's that are your unknowns. Now, the reason why I say I'm referring to the unknowns is because you'll find that with some other questions, you might have three equations. So here, in this case, there's three. Okay, that means there's going to be three unknowns. What are the x's, the y's, and the z's? So you need to figure out what those are. Now, I'm not actually going to show you how to solve linear equations by hand here, because that's going to take up a lot of time. But if you want, you can watch some other videos. I might link some in the description below for this video on how to solve these simultaneous equations. But yeah, we're going to actually use matrices to solve the simultaneous equations, not by hand. Okay. Just some examples, by the way, of solutions to these. So if you have these simultaneous equations, okay, x plus 2y equals 4, 2x minus 3y equals 1. The solution is x is 2 and y equals 1 for both of them. Okay. Now, how we got that, again, I'm not going to show you, but you can watch some videos on it. But we can actually get these using your matrices. Okay. Same with these ones. All right, so we'll skip these for now. But the idea is what you want with these questions, before I go ahead, is that you want to be able to figure out what is x, what is y, what is z, or what are the unknowns, okay, in these equations. So what is x and what is y in these equations? That's what you're trying to figure out. And you can actually do them using matrices. Okay, so let's look into it. All right, so a set of simultaneous linear equations can be represented as a matrix, as I've been alluding to before. So if you look here, the first example, for two equations, if you have two equations, that means you're going to have two unknowns. Okay. And you can see as well, if you look at the matrix, this matrix here with all these letters, generally what you'll find is when you're doing simultaneous equations, all of your matrices, so at least this first set of matrices here, will always be a square matrix. So if there's two unknowns, sorry, it's going to be a 2 by 2 matrix. If it's three unknowns like this, or three equations, it's a 3 by 3. Okay, and then it keeps going and going, 4 by 4, 5 by 5. But generally, maximum will give you is just 2 by 2s and 3 by 3 matrices. Okay, so equations like these, or simultaneous equations, can be represented as matrices. And you can see here what they've been represented to or broken down into. So let's say you have, for example, an you've got, for example, a equation like so, okay, and you've got a couple of unknowns, so here and here, and then you've got these. Well, in here, these represent numbers, okay, and these are also numbers, but these are your unknowns right here. So what they've done is they've put all of the numbers on this side of the equal side on one matrix. They've put the unknowns in another matrix, and then they put these answers in a separate matrix. So you'll see here, or actually it might be in the next part, that it's broken down into three different matrices. Okay, you've got the number matrix. This is what I'll call it, the number matrix. Okay, so if you want to write it down, okay, I'll call it the number matrix. You could also call it the coefficient matrix. The coefficient refers to the numbers in front of the unknowns, so these guys. But I'll just call it the number matrix. Here, I'll call this the unknown, or you could call it the letter matrix, whatever you want to call it. I'll call it the letter matrix. A letter matrix. Actually, no, let's call it the unknown matrix, because that's what you're trying to look for. Unknown matrix. And then this matrix here, the third one, I'll call it the answer matrix. Okay, so you want to make sure you split your equations up into these three. Okay, so you've got the number matrix, the unknown matrix, and then the answer matrix. There's three matrices. You've got to split them up into. Okay. And you'll see that in the number matrix, it's a square matrix of some sort. The unknown matrix is a column matrix, and so is the answer matrix. All right, so just keep that in mind. So it's a square matrix, some sort of column, and some sort of column matrix. Same with if you have three equations, okay? It's the same thing. You've got your number matrix, you've got your unknown matrix, and then your answer matrix. Okay, and you derive them from your equation. All right, so, and again, this is all of this is basically what I just talked about, okay? So you've got your number matrix, your letter matrix, and then your answer matrix. Okay, or sorry, number matrix, unknown matrix, answer matrix. That's what they are, okay? All right, let's keep going. So how do we solve it from there if you've split them up? Actually, before we get into that, let's practice splitting these into those matrices. So for letter A, okay, let's split that up. I've got two equations. That means it's going to be a 2 by 2 matrix, a square matrix of some sort. All right, so just put your numbers in here, or your coefficients. So I can see the first one is 2. That next one is 3. So that's for the first line. Second line, you've got 6, and then you've got -5. Okay. Watch out for that operator there. It's not 5, okay? It's a -5 in front of that 5. And it's going to be multiplied by, here you put your unknown matrix or your letter matrix. Now I can see there's only two unknowns, x and y. So that's what I'll put here, x and y. Equals, lastly, you put your answer matrix here. So here you put another column matrix for your answer, so 4, -16. Okay, and there you can see your simultaneous equations in a matrix form. All right, that's that for A. What about for B? Let's do B. So B, same principles. Okay, you just got to make sure you put your numbers in a number matrix. And because I have three equations, this will be a 3 by 3 matrix. Okay, let's start with that. All right, it's kind of hard to see, but let's just make it work. All right, so for the first equation, I've got nothing in front of that x. But remember, in front of every letter, okay, that's by itself, there is a number. It is the number 1. Okay, so if you ever see a letter by itself, just imagine that there's a 1 in front of it. Make sure if there's any operators, like a negative in there, it's a -1. But in this case, there's nothing, so that's a +1. Y, okay, I can see there's -2 for y, so -2. And for z, again, it's just by itself, so there must be a +1 there. Second equation, okay, for x, I've got a -2, so I'll put -2 for the x here. Okay, y, I see a +3. And for z, well, actually, there's no z's in this equation, so I'll put it as 0. I don't know if you guys have noticed, but I'm just writing all the x's in the first column, all the y's in the second column, and all the z's in the third column. Okay, that's basically all I'm doing. Okay, for the last equation, the third one. So there's 2 x's. Okay, I don't see any y's, so I'm going to put 0 y's. and in front of that Z is a 1, but look at that operator, so it becomes -1. Okay, just make sure you put them in the correct order, yeah? If you go on X, Y, Z, then make sure that's what you write in here. So times, here is your unknown matrix. So you've got 3 unknowns, X, Y, and Z, equals, and then you put your answer matrix here. And I can see here's my answer matrix. So -2, -3, and 4. Okay, and there is my simultaneous equations in matrix form. Okay, let's keep going. So now, after putting them in matrix form, we're going to solve them. So how do we solve these? Okay, so the reason why I asked you guys to watch the 2 previous lessons, so 5i and 8.5, is because you need to know how to do your inverse matrices. Okay, that's how we solve these. Now you'll notice, okay, that these are quite similar to what we've been doing with inverse matrices. Okay, so all you got to do, what the principle we learnt is, when we're trying to find unknowns here, all we have to do is move this matrix to the other side. But we can't divide them. Okay, you can't actually divide. It's not going to work. Okay, so in order to move this to the other side, instead of dividing, we use inverse to the power of -1. Okay, because basically that's what we learned in the previous lesson, putting these to the power of -1. Okay, so let's do this. Splitting these into matrices first. Let's do question A. Okay, first one, question A. Split them into your matrices. Yes, so you've got your number matrix. So for question A, it's going to be 2. This is X, this is Y. So the X column, you've got 2. Y column, you've got 3. That's for the first equation. Second equation, you've got 6X, -5Y. Okay, multiplied by. Okay, you've got your unknown matrix, X times Y equals answer matrix, 4 and -16. All right, so you've got your, I thought I pulled up my CAS, oops, sorry for that guys, CAS. All right, now you've got your CAS open. So what you're gonna do here now is, remember, you wanna try and move, okay, this matrix to the other side. Actually, before I get my CAS out, so the principle behind that is you want to isolate X and Y, so that means you've got to move this guy to this side. Now, you can't divide it, so what do we use? We use inverse, so the power of -1. Okay, so we have to inverse this matrix. So to do that, okay, on my calculator, let's put that into our matrix. Actually, let me rewrite this really quickly. So what this is going to become, so I skipped a step. It's because I've moved this matrix here. So I've moved this guy here. Becomes an inverse. So it basically becomes this. 2, 3, 6, -5. Oops. Inversed times this matrix. 4, -16. Okay, so that will give us the answer to our what X and Y is. Okay, so let's put it in our CAS. So you've got 2, 3, 6, -5 to the power of -1. So the power of, you can use this button, power of, and -1. So that makes it inverse, multiplied by. Make sure you put your cursor to the right. Okay, otherwise it's going to stuff it up. So times this column matrix. All right, so let's just use this guy. Oops. 4 and 16, or -16. So the answer to X and Y is -1 and 2. That means X is -1, Y is 2. Okay, pretty straightforward, I think, for that. Now, I need to just make this a bit smaller. Don't have enough space. Let's make this a tad bit smaller. So now let's do question B. Okay, so let's do B. All right, B is right there. we're going to put that into, again, number matrix, unknown matrix, and the answer matrix, those three. All right, so let's do that for B. Now, again, look at this. There's three equations. That means it's going to be three unknowns, and it's a 3 by 3 matrix. So give yourself space to do this. 3 by 3 matrix. All right, let's get the numbers going. So, and also remember, X column, Y column, Z column. All right. So the X column for the first equation, there's 1. For Y, there's -2. For Z, there's just 1. Second equation, there's -2 for X. Okay, there is 3 for Y, and there are no Z's in this equation, so 0. Third equation, there's 2 X's. I don't see any Y's, so no Y's. And there's a -Z, so -1 in front of that Z there, okay? Multiplied by, okay, the column, the unknown matrix. There's 3 unknowns here, X, Y, Z. So X, Y, Z, easy. And last one is your answer matrix. So here are your answer matrix, so -2, -3, and 4. Okay, easy. Now, remember, to solve this, all you have to do, okay, is isolate the unknown matrix. Let me just fix that Z. Okay, the unknown matrix, this guy, move it to the other side here, becomes an inverse to the power of -1 to get rid of it. All right, so what that's going to look like is, give myself some space, X, Y, Z is equal to, okay, 1, -2, 1, -2, 3, 0, 2, 0, -1, inversed times that answer matrix there. So -2, -3, 4. Okay, and that'll give us the values for X, Y, and Z, which is, okay, jump on our calculator. Alright, so click on this to get your matrix going. Now this is a 3 by 3, so we'll click on our custom matrix here, make it 3 by 3. So 1, -2, 1. Notice how I'm not actually putting letters or giving names to our matrices. You don't have to, but if you want, you can. Okay. There, now you put to the power of -1, so power of -1. Put your cursor to the right, don't leave it there, times, and that column matrix there. Now we have to use a custom matrix for this. So I see it's got 3 rows and 1 column. It's a column matrix anyway. So -2, -3, and 4. Multiply them, and there is my answer. So 0, -1, -4. Okay, so there is my answer for each of the unknowns. 0, -1, and -4. So that's essentially how we solve, okay, these sort of equations, okay, with the these simultaneous equations. Okay, you need to make sure that you've first of all understand that you need to put your matrices into your 3 matrix types. So your number matrix, your unknown matrix, and then your column, so your answer matrix. And then all you got to do is get that number matrix, bring it to the other side, but you got to inverse it and then multiply it with the answer matrix to get your values for X, Y, and Z. Essentially the same thing for all of them. Okay, let's move on. Here, unique solutions to simultaneous linear equations. So not all sets of linear equations, simultaneous ones, will have a unique solution. A set of simultaneous linear equations can be inconsistent. Okay, so if you look at here, this is inconsistent because x plus y equals 0, but x plus y also equals 1. It doesn't make sense. Okay, they have to both be the same numbers, so it's inconsistent. There's going to be no unique solution to that. And they can also be dependent. Okay, dependent meaning it really depends on what the values are here. Now, Generally, what you'll find is what this is trying to say is we need to go back to using this determinant. If your determinant, so if you go back to chapter 8.5 where we learnt about this, if your determinant equals 0, then there is no unique solution to it. Okay, which means that it is inconsistent, or it could be, what was the word that we used? I can't remember what it was, but you have to look at the previous chapters. But it will be, there's no solution, or no unique solution, or undefined. That's the word. It will be undefined. Okay, so what you would write is no solution, or no unique solution, or undefined. Another way that they also write this is if there is no determinant, there's a word called singular matrix, but we haven't really learnt about that, so we'll let that be for now. But undefined or no solution, because determinant equals 0. That's essentially how you would write your answer. Okay, so for these ones, it wants us to solve these, but before we even solve them, we have to state whether there's a unique solution or not, and then we've got to give a reason for it. Okay, so a unique solution will exist if your determinant does not equal 0. Okay, so I'll write this. Write that down here. Unique solution exists if determinant does not equal 0. And I think that is set up there. Okay. Yeah, it's already up there. Okay. So that means if your determinant is 0, then there is no solution. All right. So these ones are really easy. All you got to do is just find the determinants for these. All right. So to do that on our CAS, let's do it for A. All you got to do is det on your calculator, det, and then the matrix. So 2, 3, 5, 2. Okay, and if there is a determinant here, or if the answer is not 0, then a solution will exist for it. Okay, so let's put that in. 2, 3, 5, 2. Oh, to do that, sorry, don't forget type in det bracket and then close the bracket. And it's negative 11. So a unique solution exists. That's what you'd write here. A unique solution exists. Oops. Because, and I would write here my reasoning, the determinant is equal to 11, negative 11. Okay. For B, similar thing. Okay. B, right here. DET on your calculator, or if you wanted to be really proper, you could also put this in a matrix, name it whatever you want. Okay, 3. I'll go through that in a second when I put this in. 1, 4, 5. Okay, you could do that in your calculator if you wanted to. So let's go here. 3 by 3, yep. So 2, 1, 4, 3, negative 1, 0, 1, 4, 5. Now you could name this, remember to name it control variant, or call it matrix A if you want. So if I went dt of A, the answer is 27. So the determinant is 27. So a unique solution must exist. Okay, solution exists. Make sure you write your answer like this. If you get a question where it asks you, state whether or not a unique solution exists. Okay, or you get a question like this. All right, let's move on to the next part. All right, guys, apologies for all the cuts that you'll have noticed, or little messages popping up. I am juggling 2 other classes whilst I'm recording this, so you'll have to excuse me for, and also answering students' questions, so apologies for that, but let's get back straight into this. So now that we've come to some application questions, there's a couple of things that you need to just remember when it comes to doing these questions. So first one is, don't get too overwhelmed with what's happening because of all the numbers and of all the information here. Okay, if you keep to this principle of just knowing that you've got a simultaneous equation, so you're going to have 2 or 3 equations depending on the question here. Okay, you'll have 2 or 3 questions that you need to do, and you got to figure out what they are. Okay, secondly, it's going to be always the same principle of putting them in this form of your number matrix, okay, your unknown matrix, and your answer matrix. That's all it is. Okay, so there's 2 things that you just need to remember when it comes to doing worded questions. So let's figure out what are the equations in this question. Okay, I might use my highlighter for this every now and then. So let's read it. On Monday, a cafe sells 90 coffees and 60 teas, giving a revenue of $612. So right there, 90 coffees, 60 teas, and it equals $612. Okay. On Tuesday, the same cafe sells 82 coffees, 55 teas, giving a revenue of, this time, $558.90. So there's your other bit of information there. 82 coffees, 55 teas, revenue of 558.9. Use matrix methods to find the prices of a single coffee and a single tea. All right, so what I like to do with these questions is, before I start actually writing down my equation, I want to look at the 2 variables I'm looking for. So I'm looking for coffee and tea. Okay, those are the two unknowns that I'm looking for. The single price of a coffee and a tea. So what I'm going to do here is I start off by just making a note to myself that coffee. I'm going to use. Oh man, my handwriting's horrible. For coffee, I'm going to use the variable x. Okay, so x is going to represent my coffees, and my tea, I'm going to use the variable y. Just so I don't have to keep writing coffee and tea in my matrix equation. So I want to start with that, coffee and tea. Let me rub this out. Use another color. So it's, actually, let's use red. So it's not confusing. Coffee, so these are my first ones there. Okay, so now I've got my x and y variable. X is coffee, t is y. And I want to figure out the price for each one of these. Now, the next part is to look for the equations in these questions. Notice how I've highlighted or underlined all these in red, because this information here represents the first equation. So what's that saying is 90 of your coffees plus 60 of your teas is equal to $612. There's your first equation right there. 90 coffees, 60 teas equals 612. Remember, I've just used x and y to represent coffee and tea. There's your first equation. How easy is that? Second equation, I've highlighted in green. So the second one is, or the second day on the Tuesday, I've got 82 coffees, okay, plus 55 teas. So 55y, and that equals 558.9. And you can see already there, I presume most of you will now know what you need to do. So we now need to split this up into our number matrix. Okay, and notice how in your number matrix, because there's 2 equations, it's going to be a 2 by 2. You're just going to list down what are your variables for the x and y's here, or the pronumerals, sorry, for the x and y, plus your, times, not plus, times your unknown matrix, so x and y, which is what we're looking for. So remember, x is coffee, y is tea, and then my answer matrix, which was 612, 558.9, or 90. Remember, this represents how much the revenue is for Monday and Tuesday. Okay? All right, so let's fill this in. For my number matrix, or my pronumerals, so 90x, so there's going to, for my first equation, there's 90 of my coffees, and there's 60 of my teas. Second equation, right there, there's 82 my coffees, so this is the second day, and then 55 of my t's. Okay, now you've seen this done before in the previous part. All you got to do is get rid of this, move it to the other side, but you got to inverse it. Okay, so on my calculator, actually what this will look like now, okay, show you full working out, x, y is equal to 90, 60, 82, and 55 inversed times my answer matrix, which is that column matrix here. So 612, 558.9. Make it nice and neat for you guys. Okay, so let's put in my calculator. All right, there. I can use this guy here. So 90, 60, 82, 55 to the power of, so the power of buttons here, -1. Put your cursor to the right, don't leave it there, or else it'll stuff up. Times that by, okay, another column matrix here. So it's 612, 612, and 558.9 or 90, doesn't matter, same thing. So there is the answer for x and y. So put my answers here. X and y is equal to, now this isn't the final answer, but just make sure that you write it like this first. So you've got 4.2 $4.20, because we're working with money, yeah, so make sure you write 20 cents and $3.90. So as a final answer, one coffee costs $4.20. One tea costs $3.90. And that's it. Okay, there's my final answer for that question. Nice and easy. I think there's one more example here to do, and then you get to do your questions. All right, here we go. So same principles, yeah, of previously. You just got to make sure that you read the questions properly. Okay, so first of all, let's read it. A worker at a furniture factory can assemble 10 bookcases and 4 desks in 360 minutes. All right, so I'm going to highlight that now. 10 bookcases, 4 desks, 360 minutes. Easy. And can assemble 8 bookcases and 3 desks in 280 minutes. Okay. Use matrix methods to find the amount of time it takes for the worker to assemble a single bookcase and a single desk. All right, so first things first. Okay, let's actually use let's change. Okay, bookcases and desks. So obviously the variables here are bookcases and desks, because that's what we're trying to find. Yeah, bookcase, desk. But let's change them into x and y so that it's not confusing. So bookcase, I'm going to use x for that. And then desk, I'm going to use y. Alright, so now let's put these into our formulas or our equations. So first equation here, it's 10 bookcases. Read the question. So 10 of the x's plus 4 desks. So 4 y's equals how many minutes? 360 minutes. Okay, next one is, okay, 8 bookcases and 3 desks. So 8x plus 3 desks, which is the y's, 3y, equals 280 minutes. All right, so same principle now. You've got your 2 equations there. Now we split them up into our 3 matrices. So you've got your number matrix times your unknown matrix equals your answer matrix. Split it up into 3. So remember, this is x column, that's your y columns. All right, so you've got 10 for the first column of x's, and then 4 for the second column of the y's. Second equation, you've got 8x and you've got 3 y's. Your two unknowns are X and Y. Remember what they represent. X is bookcase, Y is desk. Answer matrix, 360. And then 280. Okay. Now, next part is, remember, you want to isolate this. Bring it to the other side. Here. Bring it here. Okay, and you want to inverse it. Okay, you got to inverse. Can't divide. Inverse. So it's going to look like this now. X, Y equals 10, 4, 8, 3. Inversed, multiplied by the answer matrix there, 360 and then 280. One more thing, notice how I always put my inverse matrix on the left hand side, okay, not on the right. And that makes sense because if I put it on this side, you have enough numbers to multiply. Yeah, but if it was reversed, as in this was here, this number of this number of rows doesn't equal this number of columns, so you can't actually multiply them if it was the other way. So just make sure you put your inverse matrix on the left hand side first before you do anything, before you multiply, sorry. Okay, let's put it in a calculator and find the time for each desk and bookcase, or bookcase and desk. So yep. Okay, so you've got 10, 4, 8, 3 to the power of -1. Okay, put the cursor to the right, times this one here, 360, 280, multiply them together. So there's the time for each, so 20 and 40. 20, 40. Okay, put it in context though when you finish. So remember what X represents? X was the bookcase, Y is desk. So you'd write as your final answer, one bookcase takes 20 minutes to make. You don't have to make, I'll just write that here, to make. And then one, what was the other one? Desk takes 40 minutes to make. And that is essentially how we solve simultaneous equations with these. Okay, so once you've done and watched this, guys, go ahead and go ahead and complete these questions for 8.7, and that'll be the final chapter for matrices. Thank you.